Hi, everyone. My name is Rishabh, and welcome to this NDSML 2021 machine learning track. Today, we're going to talk about machine learning for personalized music recommendations at scale. I'm going to briefly touch upon some of the work which we have done together with a lot of product teams at Spotify. So in today's talk, we're going to spend a bit part talking about how do we do multi-stakeholder recommendations in marketplaces. And specifically, I'm going to start by talking about bandits and ranking techniques for content recommendation. I'm going to then switch over to how do we do multi-stakeholder recommendations. And towards the end of the talk, I want to spend like 5 to 10 minutes talking about how can we leverage user and content understanding to help us deliver multi-stakeholder outcomes in a better way. So a quick fact check about me. So I'm currently a staff research scientist at Spotify. I'm based in the London office. I did my PhD at UCL. And in general, I'm mostly interested in machine learning and recommendations in multi-stakeholder and multi-objective scenarios. So a quick background on what do we do at Spotify. So my team's mission is to connect listeners and creators in a unique and enriching way. And to do that, we rely on machine learning at scale. So in general, if you look at the scale at which we operate, we have about 158 million paid subscribers. We are looking at a huge collection of tracks, over 70 million tracks. That means you have recommendation is a pivotal problem for us because you can't expect the user to kind of browse through such huge catalog, and they mostly rely on our recommendations to get the music they want to listen. We have availability across multiple markets, so that means a lot of machine learning problems around cross-market training of models and deployment across different markets is, again, quite a few interesting problems in that domain as well for us. If you look at the recommendation products, then we have playlists, we have the sequential recommendations, we have search as a learning to rank problem, we have home as a holistic recommendation problem, we have different genres and mood hubs which are personalized to a certain extent as well. So if you look at these products, then one of the ways in which we can look at these is like each of them have their own machine learning problems, and we can formulate different problems in different machine learning paradigms based on like an example would be search is a learning to rank problem, whereas radio is a sequencing problem in a sequential recommendation scenario. So again, like multitudes of machine learning problems spread across different product features. And today we're going to specifically focus on some of the work we have done on the homepage over the last few years. So again, as I mentioned, the focus of today's talk is going to be in 3 parts. I'm going to start by just talking about a single objective recommendation model and talk about one of the bandit models we've had in production on the Spotify homepage. And after we've done that, we're going to mature our discussion to more multi-objective and multi-stakeholder scenarios. So the first part, if we look at like bandits and ranking for recommendations, the question we want to ask is how can we rank playlists on the homepage? So again, like I'm sure a lot of you are familiar with like what typical homepages of different applications look like. On Spotify, for us, it means that we're looking at creating these holistic experiences which are personalized for users. So again, like each homepage is personalized to a different user. We serve over 300 million personalized playlist homepages across the world at any given point of time. So again, like we're going to talk about some work which we published at Rex's a few years ago, and the title of this paper is Explore, Exploit, Explain. So how do we balance exploration, exploitation in a bandit setting using explainable content? So before we go into detail, let's just kind of set some nomenclature for us for later. So when we are looking at the homepage, we're going to divide the homepage into rectangular shelf. So shelf is a collection, is a horizontal collection of cards. So for us, each card is a playlist, and a collection of playlists horizontally will be a shelf. And each shelf comes in with a shelf name, which is over here, your heavy rotation or recently played or jump back in. So again, we're going to touch briefly that each shelf name is explanation which we offer to the users that this is why we think that you should listen to this music or this set of playlists. So if you look at the homepage now, then you can start looking at the homepage over a horizontal and vertical decomposition. So we have a stack of shelves, and each shelf is a horizontal stack of cards. Each card is a playlist. So the question then becomes, how do we solve this problem of creating this complex rectangular grid of shelves and cards to create these homepages? So again, like I mentioned briefly that for us, shelves are the explanations. So the shelf title could be because it's like Friday or inspired by your recent listening, or because you like this genre or that genre. So again, we've kind of gathered huge evidence that explanations play a key role in how users engage with recommended cards. But then the problem becomes that if we try naive combinations of the explanation and the different combinations of these cards and playlists then becomes a combinatorial problem, right? And it's non-trivial to solve. So now we look at like how can we relax and make certain assumptions and then try to construct this homepage. So majorly, we, again, like the model which we describe and which we developed is called BART. Again, the homepage team is a huge fan of Simpsons, and we named our homepage ranking bandit model as BART as well. So it's BART, it stands for like bandits as recommendations. Bandits as responses for treatment. So in general, when we try to look at the decomposition of the model, then we have a user preference model, which could be your favorite machine learning neural network model or a factorization machine model, which is conditioned on context. So context could be anything we know about the user, including the region, the age, the listening patterns, time of day, and so on. We have a ranking procedure, which we're going to talk about next, and we have a training procedure. So again, we won't have time to talk about the training procedure in detail, but then we rely heavily on counterfactual learning, counterfactual reasoning, counterfactual training, and maximum likelihood estimation in the counterfactual realm. So if you look at it, the ranking procedure, then the ranking procedure we divide based on horizontal and vertical shelves. And each of this is powered by the core recommendation problem, which is, can we learn this action sampling distribution? So what does it mean? So we have a set of cards, which are these playlists. And from that set of playlists for each user, for each context, what we want to do is we want to know this action distribution probabilities. That can I learn this policy, which tells me like, how can I sample an action? How can I sample an action? So an action is like, how can I sample a playlist from the set of playlists, candidate playlists we have? So this is composed of an exploration strategy, which would be epsilon greedy or Thompson sampling. There's a reward function, and there is a candidate set of actions, which are the set of playlists we have in the candidate set. So if you look at how do we kind of create this homepage, then I mentioned that we have this like assumption of shelf browsing. So we assume like horizontal scrolling and we assume vertical scrolling. So in the horizontal scrolling, we say that, let's say the dotted box over here is the user awareness. And we say that, okay, I have a set of playlists, my candidate set, and I want to sample one playlist at a time and start creating these shelves. So the way we can do that is we can refer back to the playlist action distribution policy and then try to sample one card at a time. So we sample a card from that policy, we put it on 1,1. And then we can do that consecutively in a horizontal fashion. So we sample another card, we create that, we put it left, right of the first card, and then and keep on sampling it and so on. So if when we do this, then we create these horizontal shelves, which are a stack of playlist after playlist in a horizontal fashion. Now the question then becomes that, okay, I've created these multiple shelves. Each shelf comes with an explanation. Now, how do I rank these shelves on the homepage? So we can apply another bandit model over here. The second aspect of this bandit model is we're now applying this bandit on the candidate set of shelves. So previously, we were applying it on a candidate set of cards. Now we're applying it on a candidate set of shelves. So then we can say that, okay, I'm going to sample my shelf from another action distribution and then put it on the top of the homepage. And then I can keep on doing that vertically. So when we do that horizontally and vertically, we create this like whole homepage, which we serve to the user. So again, like we kind of implementation, and we kind of compared it with production models and quite a few other machine learning models. And then we found enough evidence that this kind of works a lot better than other ML models we developed. And then we kind of deployed it at scale to like almost the entire user base back in like 2018. So again, this is the model which kind of majorly powers a lot of, we've kind of developed a lot of variants over the years, but then like this is a single objective model, which is a bandit model, which powers the homepage in a personalized manner for each users. So again, the take-home messages from that quick first round was that naive combination of item and explanation is combinatorially hard, so we can break up the problem into horizontal and vertical shelves, and then bandits allow us to perform explore exploit over explainable content. A couple of things which are very important, but we don't have the kind of time to kind of dive deeper, is that it took us a lot of time and investment on our end to develop good offline-online correlation work, to develop counterfactual evaluation policies, to collect randomized data, which we use for training and evaluating these models offline. There's a benefit of explanations, which we've kind of done a lot of user studies and user research and qualitative insights on. And then like there are certain aspects about deployment at scale. All of this we discuss in detail in the paper, in the Rex's paper I referred to earlier. Great. So up until now, we've said that we can create this homepage, but so far we are trying to kind of keep the user in mind and have a single objective model. That how can we make users happy? How can we develop personalized models? But a key question to ask is that, is caring about the user enough? So if you look at a lot of these companies, which are the upcoming unicorns, and a lot of these like billion-dollar companies, are not necessarily these are multi-stakeholder problems. So what we mean by that is that we not only have to care about the user, but we have to care about, let's say, the 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 drivers on Uber or the guest and host on the Airbnb. If you are Postmates or Deliveroo, you have to care about the delivery partners and the platform economics itself. So basically, the point we're trying to make is that a lot of these upcoming companies and a lot of these user-centric platforms are not necessarily user-centric platforms. These are platforms which have multiple stakeholders. And in an ideal recommendation world, we would optimize for objectives across these combinations of stakeholders and what they care about. So just a quick couple of examples without going into much detail. If you look at Uber Eats or Deliveroo or whichever is the food sharing app across in your country, then we have three sides: the eaters, the restaurant partners, and the delivery partners. And each of them care about specific objectives. And then when you're kind of showing recommendations on the Uber Eats homepage, then you have to kind of be considerate across all different objectives. So there's a very nice blog post from the Uber Eats team, which talk about how they evolve their recommendations to a multi-objective version, which is linked at the bottom of the slide. A quick example would be Etsy as well. So Etsy is also a three-sided marketplace. You have buyers, you have sellers, you have platform. The buyers want to choose unique products, and they want to kind of look at, discover other products as well. Sellers want to reach more audiences and kind of reach out to potential buyers, run campaigns more effectively. And the Etsy itself would want to maintain a healthy platform, and it want to speed up the buyer-seller communication and kind of have some of those selling decisions rather quickly. So again, these are all examples wherein we can think about multi-objective methods. And there's a wisdom talk, which is linked at the bottom of the slide, which talks about a lot of their multi-objective models in detail. The question for us then becomes like, we are also trying to combine and connect the listeners with creators in a unique and enriching way. So what that means is, up until now, we were looking at user satisfaction as a sole objective. That I have a model and I want to minimize user dissatisfaction or maximize user-centric objective. But now, when we start having user-centric, supplier-centric, and platform economics, now the problem becomes a multi-objective problem. So this is where finding the optimal solutions which satisfy multiple objectives are needed. And this is where we come at, like, start looking into multi-objective methods, Pareto optimum methods, and so on. So again, a lot of work in the machine learning world has gone into multi-objective optimization in different aliases. But in a recommendation scenario, typically in a contextual bandit scenario, this is like maybe not so advanced an area as such. There's some work recently wherein we are trying to balance multiple objectives in a bandit setting. So let's look at a few examples of what some of these objectives could be. So these are just some rough examples and some correlation plots from some random collection data. So if you look at user satisfaction, I could care about their stream time, we can care about clicks, we can care about items consumed, and so on. On the supplier artist side, I could care about artist diversity, that am I giving exposure to multiple artists or not? And then maybe there is a set of promotional suppliers, that some artists who are not getting enough coverage or they're not getting enough exposure, and we want to promote based on some events, based on some global events or some different occasions, we might want to promote a set of suppliers as well. So if you look at some correlations, then different SAT metrics, the satisfaction metrics, are correlated with each other. That's great, because then if you optimize for one, somewhat you get the others for free. There are these supplier metrics which are almost neutral. So what that means is that if you really care about artist diversity or supplier diversity on your platform, you should optimize for them explicitly, because you don't get them for free when you only optimize for satisfaction, user satisfaction. On the other hand, like some of these promotional objectives might start hurting some of the other objectives. So they are like anti-correlated, and then you really have to do a nice job at finding Pareto optimal solutions which kind of satisfy all your objectives. This is some work which we published at KDB last year, wherein we're looking at how do we do multi-objective bandit models in a contextualized bandit setting. So again, I kind of briefly mentioned that we have multiple stakeholders, and now we are looking at solutions which offer these multi-objective optimization in the bandit setting. So the core principle of our developed approach relies on optimizing this Gini, generalized Gini function. So the generalized Gini function is a special form of ordered weighted averaging, OWAs. And the unique aspect about these functions is that they preserve impartiality with respect to individual criteria. And specifically, they respect the Pigeon delta transfer, which means that they prefer allocations that are more equitable across objectives in our case. So let me give you a quick example. So the Pigeon delta transfer principle says that we want to have a gap diminishing transfer from someone with more to someone with less, thereby decreasing inequality. So this is some work coming in from the early 19th century, but then it has a very nice principle that if you, let's say, have three different stakeholders, and this is a distribution of the quantity of units which they have, then the Pigeon delta transfer says that I want to decrease the inequality and transfer from someone with more to someone with less. What that means for us is that I'm going to take in some bits from the rightmost and then transfer it to the leftmost or transfer it to the middle. So going in from the right to left, now we see that this transfer has kind of decreased the inequality across anything. So for us, we try to apply this generalized Gini function across different objectives, across different stakeholder objectives. So essentially, if you look at this Pareto principle, the Pigeon delta principle, it's kind of a gentler, kindler cousin to the Pareto optimality, which we kind of are very used to in the multi-objective world. So Pareto optimality refers to efficiency, whereas this Pigeon delta transfer refers to equity across objectives in our case. So essentially what we do is again, like as I described before, we have an arm selection strategy in a bandit setting, wherein we want to learn like the probability distribution of selecting an arm. Now for each bandit round, we get some features. These are the contextual features. And then if we choose an arm K, we might have observed a linear reward. But the problem is that in our case, we take a vector of rewards because it's a multi-objective model. So you don't just have one reward, you have a full vector full of rewards for yourself. Now the question is that if we know the vectorial mean feedback for each arm, for each playlist, then it's a simple problem. We can do an optimal full sweep and then find the optimal arm. But because it's a contextually banded problem, so we don't know that. The outcome and the feedback is context dependent. So now we say that the optimal policy is given by maximizing this G function. This G function is the Gini index function, which I was talking about 2 minutes ago. So this G function preserves this Pigeon delta transfer. So now it's trying to kind of find an allocation, find an arm selection strategy, which is going to give equitable allocations across the different stakeholder objectives. So it gives us some very, very nice empirical results. So again, if we just look at some user-centric objectives without any business objective, then we find good evidence that optimizing for different user satisfaction objectives also kind of performs better than optimizing for each specific objective. So then the takeaway for that was very nice, that even if you just care about users and you're not a marketplace, you don't have other stakeholders, even in that case, if you optimize for multiple interaction metrics, it performs better for each metric than directly optimizing that metric. It was a fascinating result for us because we realized there's a chaining effect across these metrics. Like you have to have a click in order to have the user stream this song for a few minutes. Now, you have to have multiple such few minute streams in order for a user to have a very deep, in-depth session with our recommendations. So again, like there is an inherent latent structure across these objectives and metrics you care about, which the model in a multi-objective world can kind of benefit from. The moment we start adding competing objectives like a business objective like gender exposure or diversity, then we are starting to see that the multi-objective methods are giving you significant gains in the business objective without severe losses in your user-centric objectives. So again, it kind of alludes to a great point that it need not be a zero-sum game. So perhaps we can get gains in the business objective without hurting user-centric objectives. So again, I'm not saying that this is true for each cases, but then based on the objectives, based on the correlation and anti-correlation between your objectives, maybe there is a way in which you can have all boats rise at once, that you get gains across all your objectives if you're modeling the problem in a good multi-objective manner. And also we find that the way of doing multi-objective matters a lot. So again, like it's not that any naive combination of multi-objective works. We tried a few variants and we tried other approaches, But then like we realized that how you do these multi-objective machine learning, it matters a lot. Again, this is something which might be obvious to a lot of us. Anyway, great. So the take-home message is for us being that there's an interplay across objectives, and in a multi-objective world, it need not be a zero-sum game. So again, like I've not talked much about objective balancing and two-stage ranking, some of which we have recently published upon. So more details about these are in the KDD paper or on the Spotify research website. Finally, let's spend like the last 5 minutes talking about how do we make this decisioning of multi-stakeholder decisioning better by leveraging user and supplier and content understanding. So what we want to do is like we have this core multi-objective method, and how do we enrich the user aspect, we enrich learnings about content and suppliers to make better decisions. I'm just going to give like one example without going into too much detail. This should give a sense of the kind of problems we kind of tackle in this area. So in leveraging user understanding, we did some work which we published at the web conference last year around consumption diversity. So in this work, we said that we found evidence that there are different types of users. So some users are very specialist, that they have a very narrow listening horizon, whereas some users are very generalist and they have a very wide horizon of listening. And they kind of consume music from multiple genres, multiple artist groups, and so on. And it's not like a 0 and 1 binary bifurcation, but like there's a spectrum. And the plot on the bottom shows that like different users are in this generalist versus specialist spectrum. But very importantly, we found evidence that generalists and specialists exhibit different retention and conversion behaviors. Now, this is great that we found that specialists want something different, generalists want something different, and generalists usually want more diversity in our recommendations. And if you're not giving diverse recommendations, then they might kind of churn more. Again, great findings. Now what we want to do is like, okay, great. Generalists want more diversity, so maybe we should optimize for diversity as one of the objectives later on as well. Just a quick example of how can we leverage content understanding. So in content understanding, when we're looking at bandits, we have to talk about rewards. So what we did was we looked at some personalized user and playlist of their reward functions. A quick example would be that if you look at different playlists, then different playlists have variation across consumption time. So sleep playlists users will consume a lot more than general playlists. Even there, we observe like variation across users, that jazz listeners consume jazz and other music for longer periods than average. So again, there is heterogeneity across playlists, there is heterogeneity across users. So then like, why should I have a single reward function for all users and all playlists? So the naive way, and in the bandit model we talked about in the first part, we could have a single reward function which says that if a user streams, let's say 2 minutes or 3 minutes, that's great, I'm going to give it a +1 reward. But then that's a global distribution, that's not personalized. Ideally, we want individual distributions for each user for each content type. But then it's too sparse, too granular, very noisy, and it's very costly to generate and maintain in production. So this is where we kind of come back and say that maybe we want to co-cluster users and content together and learn these distributions for reward functions. So the way in which we tackle this problem is that we look at users and playlists, and instead of clustering them separately, we cluster them together. So co-clustering is a way to do that. And essentially what that gives is there's a bunch of users, there's a bunch of playlists, and now we can zoom in on those users and playlists and see what the distribution of consumption of those users for these playlists is. And once you have these specific personalized distributions, now you can define how you want to define the reward functions for here. And essentially, like when we did that, then we observed great gains, that now you're training your bandit models in a very personalized way, and you're considering not only the user, but also the playlist and content aspects to define your reward functions. Quickly going into one last part about how can we leverage content understanding as well. So we published some recent work at Wisdom conference earlier this year, wherein we were trying to kind of shift consumption towards diverse content. A few minutes ago, I mentioned diversity is important. Diversity across suppliers is important. So we try to develop these reinforcement learning sequencer, which gives us more diversity across consumption. So the way we formulate this RV problem is like, again, we try to sample an action, and the action is you have a bunch of tracks, and now you want to kind of pick one track to show to the user in a sequential radio setting. I'm not going to go into detail, but just giving you a rough outline of the model, we have a session summarizer, which summarizes the current session of the user. And then we can learn these dynamic user embeddings based on real-time interaction features. And once you do that, then you can develop a feedback aware model that you know what the user is responding to with skips or streams, and then you kind of try to score each candidate track. Once you have these scores, then you can define your softmax logic function, which gives you these sampling probabilities in the RL sampling setting you have. And once you do that, then we show that we are able to shift consumption towards a bit right. So on the x-axis, we have some diversity measure, and the right we are, the higher the diversity is. And again, like when you try to do that with this RL model, we show evidence that we're able to shift consumption a bit towards more diverse content. So again, that's the detail. That's the summary of it. That when you have the score multi-objective balancing model, you can leverage user understanding, content understanding, and supplier understanding to do better algorithmic balancing decisions in production. So the summary of it being that understanding users helps in pushing other objectives without hurting key user metrics. Understanding suppliers helps in developing the right approach so that we can kind of take care about supplier goals and expectations and diversity. And content understanding allows us to know when to focus on what objectives. So I'm just going to end in a bit by just giving a quick background on some of the public data sets we've released. We've released 1 million playlist data sets. We have released 100,000 podcasts and 1 million sessions with user interaction feedback as well. And if you're generally interested in this topic of multi-stakeholder problems, we have a 4.5-hour tutorial at KDD last year, which talks about each of these aspects in a lot more detail. With that, I want to thank you, and maybe we can take some questions in the chat now. Thank you.